Okay, in this video we're going to be talking about squares and rhombi, or if you prefer rhombuses. And a rhombus, which we're going to start off with, is just a quadrilateral with four congruent sides. Now, one of the things that you'll notice about a rhombus, since it has four congruent sides, then that means opposite sides of a rhombus are congruent. And since opposite sides of a rhombus are congruent, it happens to fit into a category of another type of quadrilateral that we've already talked about, which is a parallelogram. Remember that one of the properties of parallelograms, one of the theorems that we have, says that for a parallelogram, opposite sides are congruent. Well, since we have this figure here with opposite sides congruent, that means a rhombus is a special type of parallelogram. And that's going to be important because, as we've seen before with, for example, rectangles, which are also a special type of parallelogram, since a rhombus is a special type of parallelogram, that means that all of the properties of parallelograms are also properties of rhombuses. So we can use those in solving different types of problems. Now, rhombuses also have some particular properties of their own, and we're going to express these using the rhombus theorem number 1 and rhombus theorem number 2. Rhombus theorem number 1 has to do with the diagonals of a rhombus. And here I've got a rhombus. Let's call this rhombus A, B, C, D. And this rhombus here is drawn pretty close to scale, and you may in fact be able to tell something about the diagonals of a rhombus. In particular, if you look here where the diagonals intersect, you may notice that it appears that those diagonals, they look like they are perpendicular, and in fact that is the case. The diagonals of a rhombus, this is going to be our rhombus theorem number 1, the diagonals of a rhombus are perpendicular. So right here where they intersect, that means we have right angles. And that's a property we're going to be using in just a minute when we look at some example problems. Rhombus theorem number 2 also has to do with the diagonals of a rhombus, but here it has to do with the diagonals of a rhombus and where they intersect in these corner angles here. And in particular, what we're going to find is that where the diagonals intersect in these corner angles, it bisects those angles. So we're going to say each diagonal of a rhombus bisects a pair of opposite angles. So here we have a pair of opposite angles, angle A and angle C. This diagonal bisects this pair of opposite angles. This diagonal, diagonal BD, bisects this pair of opposite angles, angles B and D. All right. So let's take a look at how we're going to use some of these properties of a rhombus in solving some problems. So here, for example, number 1, it says use rhombus ABCD to solve these problems. So for example, 1A, I'm told AB is 7x plus 3, DC is 10x minus 6, and I'm looking for the value of AD. Well, first thing I note that AB and DC, those are two sides of a rhombus. Since I know all the sides of a rhombus are congruent, that means I can set these values equal to each other. 7x plus 3 is equal to 10x minus 6. And let's see here. If I subtract 7x from both sides, then I get 3 equals 3x minus 6. If I add 6 to both sides, then I get 9 equals 3x, which means x is equal to 3. Now I'm looking for the value of AD. Now I'm not given an expression for AD, however, AD is just another side of the rhombus, and I remember for a rhombus, all four sides are congruent, so I can just use one of these values here. Let me use AB. So if I know the length of AB, then I'm going to know the length of AD as well. So AB is 7 times 3 plus 3, which is 21 plus 3, which is 24. Therefore, AD must be equal to 24. Example 1b, I'm told AC, this diagonal, is equal to 32, and I'm asked for the length of EC. Well, I remember that since a rhombus is also a parallelogram, and since in a parallelogram one of the properties is that the diagonals bisect each other, then I know that if AC is 32, then EC must be half of 32, which is 16. Again, I'm using the properties of a parallelogram, since a rhombus is a particular type of parallelogram. Finally, we have an example here with some angles. The measure of angle 1 is 2x plus 20. The measure of angle 2 is 5x minus 4. And I remember from my rhombus theorem number 2 that my diagonals of a rhombus bisect these opposite angles, which means that angle 1 and angle 2 must be congruent. So I've got 2x plus 20 equals 5x minus 4. And let's see, let me subtract 2x from both sides. It gives me 20 equals 3x minus 4. And I'm going to add 4 to both sides. That gives me 24 equals 3x, so x equals 8. And that's what I'm looking for. So that's example 1c. Now, in the rest of these examples here, D, E, and F for the rhombus, you're asked, or you're given information about some of the different angles. And I'm going to leave these for you to solve, but keep in mind, you know a good deal about the different properties of a rhombus. You know that all these angles here are right angles. You've got these 4 triangles here. You know a lot about the properties of triangles, so you should be able to do the rest of those examples on your own. Okay, the definition of a square: a quadrilateral with 4 congruent sides and 4 right angles. Now, once again, we're going to note that a square has properties not only of a square, but also of some other types of quadrilaterals. In particular, notice that since a square has 4 congruent sides, well, a square meets the definition of a rhombus. So a square is also a particular type of rhombus, since it has 4 congruent sides. A square is also, notice that it has 4 right angles. Well, that means it meets the definition of a rectangle. So a square is also a particular type of rectangle. And also, since it has 4 congruent sides, that means it has both pairs of opposite sides are congruent. So that means it is also a particular type of parallelogram. So for a square, not only does it have these particular properties of a square, but it also has all the properties of a rhombus, and all the properties of a rectangle, and all the properties of a parallelogram. Now, in example number 2, you're asked to find some different values using this figure here, this square, and I'm going to let you do those on your own, but notice that for a square, you know that all 4 sides are congruent. You know that since it's a rhombus, its diagonals are perpendicular. They also intersect, or they also bisect each other, which means that you know that these are all congruent, which means that each one of these 4 small triangles you have here are isosceles triangles, and you also have right angles here in each corner. You know a lot about the different shapes here in this square. So you should be able to figure out, should be able to work out those examples on your own. Also notice down at the bottom of your notes there is a table there, and it asks you to identify the different properties of these 4 different types of quadrilaterals that we've looked at so far. So see if you can fill in that table, just checking each one of the boxes, if each one of those, for each one of the figures, if they have that particular property. And we'll look at these examples and also the table in class tomorrow.